We're going to start up on Unit 7.2, which is verifying solutions to differential equations, which is exactly what we're going to be doing. And to start off with this, I'm just going to go right into an example. So what does it mean to verify a solution for a differential equation? So what we have over here on the right, what we have is a differential equation, this here, right? This y double prime plus 4y equals 0 is a differential equation, and we want to see if this y is a solution. So the way we check is that, well, we're going to plug in y, basically, right? We're going to plug in 4 cosine 2x in for this y, and then I need to find the second derivative of y in order to plug in the second derivative here and see if that gives me 0. And if it does, then this is indeed a solution. And I've verified my solution. So what do I need? I need y double prime. So I need to first get y prime. So the derivative of 4 cosine 2x, the 4 comes out. The derivative of cosine 2x, know by chain rule that that's going to be times 2 and then negative sine 2x. Now that's by chain rule, okay? I know how to do the chain rule. U is 2x. The derivative of cosine u is negative sine u times u prime. The derivative of 2x is just 2. So that's why I put that 2 there. Plus, okay, so I got, what does this simplify to? Let's just write right away what it simplifies to. This is negative 8 sine 2x plus the derivative of 6 sine 2x is just going to be times 2, because by chain rule, cosine 2x. And then I'm just going to do that real quick, and I have y prime plus 12 cosine 2x. And this is y prime. Now I need y double prime. I need the y double prime is what I'm going for. I already know y they give me, right? So I need y double prime. So I need to get the second derivative, and I differentiate this whole thing again. The negative 8 is going to come out, right? Times 2 by chain rule is negative 16 cosine 2x. The 2 is going to come out again, but it's going to be negative because the derivative of cosine u is negative sine u times u prime, right? So it's going to be negative 24 sine 2x. Now I have y double prime. So with y double prime, hopefully, let's see what happens when I get y double prime and I add. So y double prime is negative 16 cosine 2x minus 24 sine 2x. That's y double prime. I substituted for y double prime here, right? Y double prime plus 4y. And I want to check to see what it's equal to. It should, if it's a solution to this equation, then it should be 0. Plus 4 times y. Y is 4 cosine. I'm taking it from here. Y is 4 cosine 2x plus 6 sine 2x. Put it all in parentheses. I distribute the 4. What am I going to get? I'm going to get negative 16 cosine 2x minus 24 sine 2x plus, and I distribute that 4, 16 cosine 2x. And then I distribute the 4 to the 6 sine is going to be plus 24 sine 2x. And if you notice, this cancels with this, and then this one cancels with this. I get 0, and this is indeed a solution. Now this whole process that I went through is me verifying that this is a solution to this differential equation. This is your differential equation, and you verified this being a solution. Let's take a look at another example. Here we have this function here. Let's see what they're asking for. Let's pick a pretty color. Okay, now they have the equation y equals 2, 6, blah, 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 is a particular solution of which of the following differential equations. Okay, so to do this, right, I know that y prime is going to be plugged in often in each one of these, right? So I'm going to start off with getting y prime, and then I'm going to see if it's a solution to a. So I'm going to check a first. All I would need is y prime. So I'm only going to start off with that. So y prime is equal to, what's the derivative of 2e to the 6x? The derivative of negative 5 is 0. So all I'm differentiating is this first term. So it's 2 times the derivative of e to the 6x, right? So we need to remember how to do this. And again, it's just chain rule, right? What's the derivative of e to the u? It's e to the u, right, times u prime. So in this case, it's going to be e to the 6x times, what's the derivative of 6x? 6. And then you get 12. So now I know what my y prime is. My y prime is 12 e to the 6x. And I'm going to check a because all that was missing for this equation, right, the only thing I don't know is y prime. So I'm not even going to bother. Maybe it's not a, in which case then I try b, and that's all I would need for b as well, right? All I would need is y prime because I'm given y. So if I'm trying to check, right, so maybe it's not a or b, but then at that point, then I need to start doing the second derivative, right? Because then if both of these are wrong, then I need to check c and d, in which case I need to differentiate this one here. But I'm not even going to bother wasting my time with that because I'm going to start with a. I'm going to start with the simple one. So let's see. So a says y prime minus 6y minus 30. And they want to know if this equation is a solution to this differential equation. So y prime, I just found out, was 12 e to the 6x minus 6 times, and then instead of writing y here, I write the expression they gave me for y, 2e to the 6x minus 5 minus 30. And I want to see if this equals 0, because if it does, then I know my answer is a right away. So 12 e to the 6x minus 12 e to the 6x plus 30 minus 30. Does this equal 0? Yes, because this cancels with this cancels with this. 0 equals 0. This is my choice, and I got lucky, and that's it. I wouldn't need to check this. If this did not equal 0, if I did not get 0 equals 0 here, and I got some number over here, oh, here we go, right overhead, nice and low. Beautiful machinery, very close, saw the whole thing. Beautiful helicopter. Anyways, okay, now, yeah, back to where we were. Okay, if it's the case that you have, you found out that this doesn't equal 0. Let's say the left-hand side I got 1, and then 1 doesn't equal 0. Okay, then you would try b. You'd plug in again. And if you didn't get b, then you would have to take the second derivative of this, right? Then you'd say, okay, y prime is going to be 72 e to the 6x. And then you'd plug that in there, and you'd see if it's c or you'd see if it's d. But I found out that it is on the first shot that it was a. So we're good. Okay. Determine whether the given function is a solution to the differential equation. Okay, so now I'm given the differential equation, and I got to see which of these is going to give me a solution. So let's try this one out. Okay, so in this case, right, now I want to check a. So what do I need to do in this case? I need to take this, I need to get to the second derivative, right? So the first derivative of this potential solution, the derivative of negative cosine. Well, the derivative of cosine is negative sine. So it's negative 1 times negative sine is just positive sine x. Then the second derivative is just going to be cosine x. Right? The derivative of sine is cosine. Okay, now I plug into this because now I have everything. I got f of x and I got f double prime of x. And let's see if it's a solution. So I got f double prime of x minus f of x should equal 0. Let's see. So I got cosine x minus negative cosine x. We got to be careful, right? Because otherwise we would think it equals 0, which it doesn't, because I got cosine x minus negative cosine x is cosine x plus cosine x, which is 2 cosine x, which does not equal 0. So this is not a solution. This is not. This one is wrong. Now let's check the next one. Okay, so again, I got to just do the same game here. I got to say the 2 comes out. The derivative of e to the negative x is e to the negative x times the derivative of negative x, which is negative 1, which is negative 2 times e to the negative x. Okay, so don't let that confuse you. That's a negative 2 here. I'm not going to rewrite it because I just need to find the second derivative. So the negative 2 comes out, right? It's a negative 2 right here, times the derivative of e to the negative x again is negative e to the negative x, and then this just simplifies to 2e to the negative x. And now I have f double prime of x, the second derivative. So I could check again. I could write the differential equation is f double prime of x minus f of x equals 0. F double prime of x is 2e to the negative x. F of x is 2e to the negative x, and this, in fact, does give me 0. This is 0 equals 0. So this is a solution. Now the question that's being asked here is this one, is this going to be a solution, right? Because there could be more than one that actually solves the differential equation. So there could be multiple solutions for one differential equation. So let's check to see if this is also a solution. So f prime of x. K we're going to assume is a constant. The derivative of k e to the x is just k e to the x. The derivative of that is, of course, again, just k e to the x. And I believe that this will be a solution because look, f double prime of x is the same thing as f of x, which is the same thing as f prime of x. So of course, f double prime of x is k e to the x minus f of x is k e to the x. And does this equal 0? Yes, it does. So these two were solutions, B and C. And they're of a similar form. There's this negative x here. Other than that, this, if it said positive x, this would be a sub set problem of this. K to the x is for any k. But okay, so they're similar, but nonetheless, okay. They're both solutions to this differential equation.